ffconf. I've got no speaker notes, so I'm basically just going to make this up, because if I have speaker notes, this whole thing is way too fragile and it all breaks. So Remy emailed me over the summer, and he said, can we get like a massive disco ball coming down from the ceiling? And I said, no, I don't have a disco ball. The thing is, you can do that. You absolutely can. But to do hardware, you do need to be in the venue at least a day before to kind of set it all up. And also, I'm lazy. So I was like, I don't really want to have to do all of that work. But I couldn't get away from the disco theme. One of the reasons, when I was in lockdown, I started listening to all these different genres of music, and one of them is actually called day disco. And I was like, it's all coming together. Let's see if this is, I thought so. There we go. It's the kind of relaxing, almost tropical beats that you would listen to when you're sitting by a blue pool or the sea and you've got a drink in your hand and you're basically not stuck in a house in rainy UK, right? So this is what we're going to do today right now. We're going to relax after a long day, and we're going to sit back, drink in hand. No drinks yet? They're coming. So the first thing that we need is we actually do need this music. Now, the way that I usually approach making music is to start with the percussion. I'm going to do this using the Web Audio API, because that's what I'm familiar with. There's 4 kind of ways that you can get noise into the API that you can then use and manipulate and change. First one is HTML elements. They're your friends. Anything in an audio or video element, you can grab that. You can go and fetch a file and use the file. We might get onto that later. You can create an oscillator. This creates a sound wave, and you can just play it. Or you can stick some data into a buffer, and you can use that, because at the end of the day, audio really is just data. So, I've noticed today we haven't really seen that much code, so hi. Last thing. 5 o'clock. I'm creating an audio context where I can get all the functionality of the audio API. I'm creating a new oscillator node. So the way that we want to think about nodes is they're the kind of little block of something that is happening, which connects to all my other blocks, and eventually we make something very cool happen, right? The options that I have got for an oscillator is the frequency. This is how low or high I want that sound to be. And the type of waveform. So I've got a sine here. This is one of those nice smooth waveforms that you see. So I need to connect that to my speakers, which is what you're seeing there. The oscillator node is being connected to my output. That's my speakers. I'm starting it right now, and I'm going to stop it in 0.3 seconds time. So this current time property of the audio context is super important. It's very accurate, it's right there, and I can just call it whenever I want. So this is the one that is now playing twice for me. There's not really a lot going on there. A sine wave, if you just play it for 300 milliseconds, it's just going to be like a little, boring sound, basically. It's like Morse code. The magic comes when you start to manipulate those numbers. So I've got the frequency playing at the same value throughout these 300 milliseconds. What I actually want to do is I actually want to drop that frequency down as it plays. So I want it to start, and this one's starting quite low. This one's starting at, 130? That's actually quite a low sound. If it was higher, it would hurt your ears, so I'm being nice. But I'm going to drop it all the way down to 1, like super low, as the tone is playing. This is what this linear ramp to value at time is doing. It means that I'm not just quickly dropping this frequency, I'm dropping it over 300 milliseconds, nice and gently, right? The other thing that I want to do is I want to drop the volume as this plays. So that's what this is doing in the next part. I need another node for this because the oscillator node doesn't have volume unto itself. I need to create a gain node and attach that to my oscillator So I'm going to have an oscillator node, I'm going to attach it to a gain node, and then I'm going to attach it to my speakers. And I'm going to do exactly the same with the gain as what I'm doing with the frequency. It's going to start off a value at 1, which is like normal play volume. And as those 300 milliseconds pass, I am going to slowly drop that volume down. Now we have a kick drum. Just like that. Thank you. Yes. This is a really, really easy way to get started. Like, fire up an oscillator, play with those numbers, make some drums. Cool. We can play kick. The most useless slides. Like, all of these slides. Yes, okay, yeah, we played the kick. Super cool, Ruth. I'm going to change the frequency of that oscillator. So I'm going to raise it just a little bit. Everything else I'm going to keep the same. And I've got a tom. It's a highly synthesized tom, but you get the idea, right? Kick, tom. Almost done. Ready for that? The other thing that I'm going to change is I'm going to change the type of waveform that we have in the oscillator. So before we were using that nice smooth sine wave, I'm going to change it to a triangle wave, so it's more angular. You can have a square wave or a pulse wave, and you can have a sawtooth wave as well. You can go beyond this. You can create the values you want for the wave and stick them in a wavetable, but it's kind of outside the scope of just this sort of beginner code. So up the frequency again here. So this one's a little bit higher, and we're using a triangle and laser, right? There we go. So if you ever wanted to know how to make a laser sound, that's it. We're done. I'm probably not going to include them in my drums, but it's just so much fun to make a laser. The other thing, I want a clap sound. Now yeah, thanks. Yeah. I'm not going to record you doing it. I never liked music with claps in. And then everything changed in the last 3 years, right? So I'm like, yeah, I want to do that. This is quite hard to synthesize. It is possible, but it's a little bit harder. And rather than trying to do it with the techniques that I was just showing you, I'm actually just going to get a file that plays a clap and use that. It's like a tiny little sound file. We usually call them samples. So if you hear people talking about samples, they're usually talking about like small sound files that have been recorded. I'm going to get it via an async function. So I'm going to go and fetch it. Then I've got to take the data from that file and put it into the audio API. So I'm just basically decoding it into what we call an audio buffer here. Once I've done that, I can create my play clap function, which is a little bit like the other functions. This is just going to play the noise. And I'm creating another node here, which is the buffer source node. So I'm taking that data I've got from the file, and I'm going to stick it in here. I'm going to connect it to my speakers, and then I'm going to play it. Cool. I can promise this up now. This is actually really useful, so I can make sure that all my files are loaded before I actually play them, which when I'm working with files is going to be good. You're not going to see it on here because I'm running off localhost. It's all very instant anyway. But there are a couple of examples later where it does become important because you're loading more than one thing in. Play clap. Cool. Right. I really wish I had notes. I have no idea what's going to happen now. Like, what have we got next? Oh, cool, yeah, step sequencer. I've got my drums. Now I need to play them together and like create a track and do all that kind of stuff. So I am going to whip up a very quick step sequencer. It's a little bit more complicated than it looks. This is one of the links that I am actually tweeting out, so you can actually go and have a play with this, and you can see how it's been written. Basically, I've just got my 3 sounds going down, and then I've got sort of 8 buttons going across. And the idea is, if I can see this on the screen, where is my... I cannot. Thank you. To be fair, it's probably better if I use my laptop. There we go. It's too much equipment up here. Let's do that. When we play it, if it's highlighted, it's going to play, is basically what's going to happen. She says. Right? Your basic step sequencer. I kind of want to up the BPM, but I'm really struggling with the mouse and the projector and all the things, so we'll just leave it like that. Cool. Drum beat done. There are loads and loads of examples of this all over the internet. We're talking synthesizers, sequencers, all the rest of it. This is one of the most recent, which is my favorite. It's Roland 50 Studio. And you'll see that the thing I just showed you is a very simplified version of this, which uses this kind of interface. You've got the time going across the horizontal axes, and you can select when you want the sounds to play. And you've got each sound going down. And you can mix it up and change it, and they've got a bunch of these. Further reading, web audio. There is this article that Chris Lois wrote quite a while back, actually. It's called Making Drum Sounds with the Web Audio API. And yes, the code has changed slightly over the last few years, but it's a really good article to get you started understanding all the ideas and understanding how you work with the Web Audio API, and you can basically make a bunch of drum sounds. Some of the sounds that I was using there have been taken directly from this article. You can also make nice snares with like filling a buffer with random noise and making some white noise and then using the same techniques to kind of drop things off and all the rest of it. So I recommend starting there if you haven't. The timing that comes up in that step sequencer that I showed you is actually probably the most complicated bit. I'm using a set interval of all things to like look at the next chunk of time and work out when I want things to be played. And then in my request animation frame, I'm using that data to actually play it. So it doesn't matter that the set interval, when it actually runs, all I need to know is what's going to happen so that my request animation frame, when you're actually going along the time, knows when to play stuff. That's that second article. There's way too many Chris's in this talk. It's on web.dev. Look, web.dev. And it's all about audio scheduling. So that's a good technique. And then there's also a more advanced version of the step sequencer on MDN because I wrote that article. So further reading. Homework, folks, homework. Some of you may have noticed I was actually pressing buttons here. That's because I do have a MIDI controller, and this is going to absolutely break it by trying to hold it up. I've got a MIDI controller. This is how high I can get it, which has got my sounds on when I press the button. This is a controller. It doesn't actually play sounds by itself. Instruments play sounds by themselves. Most electronic instruments these days are MIDI enabled, so if you do have something like a keyboard, a synthesizer, something like that, that will send MIDI signals as well. This one just sends the MIDI signals. I like this one because it's got lights, and that's basically it. But it's arcade buttons. Oh, they're so nice. You can get much cheaper ones than this, by the way. All I'm doing, and it is really relatively simple, is just requesting access to that from the navigator. And the on-MIDI success function is basically just looking at it and waiting for numbers to come in. And then I'm going, oh, have you got this number? I want to play this sound. Oh, I've got this number. I want to play this sound. MIDI failure is just, oh, it doesn't work, sorry. There is, and I'm hoping this works as well, another code pen. I actually made this. It's not, but I'm wondering whether it's just because. Damn it. Internets. There was always something that wasn't going to work. What that code pen I just showed you does is it actually logs the values that are coming in from the MIDI controller when you actually press it, or when you turn a dial, or when you interact with it at all. And that is so incredibly useful. Every single time I plug in something different, I will go and use that code pen to try and work out what the values are, because they tend to vary per instrument and per controller. Whew. Drums done. So, how are we doing? Yeah, it's all right. We probably need some bass. I was thinking maybe some chords. I quite like a melody. I'm going to cheat. HTML's like a big warm hug, isn't it? Like, oh, by the way, I want to do all these things. Oh, thanks for doing it all for me. I really appreciate it. That's it. Track made. Well done, everyone. Let's see if this one's working. I'm really sorry, Sarah. I keep pressing your keyboard, thinking it's mine. It's breaking your laptop. This is quite interesting. I've used the audio element in my page, and I can actually expose that kind of track to the operating system, to my hardware keys, to the browser, and I do that via the Media Session API. So this basically lets you specify things like metadata about what is playing, and it also lets you hook into some sort of actions when media is playing. So actions like play, pause, like move the track forward, seek through it, go to the next track. There's quite a few options for this. Like you can also do it with slideshows and saying like next slide, so anything sort of media related. This is a super interesting API. Now, it's hard to show a demo of this because I need to come out of full screen. And as you have seen, it's a pretty fragile thing going on here anyway. And also it sort of differs depending on what device you're on, what operating system you're running, and all the rest of it. So I've actually grabbed a few screenshots. Oh, code first. This is me just setting up the metadata for that track and telling the Media Session API that I want to use it. And this is how you hook into those action handlers that I was talking about. It's a good idea with any of the actions in this API to use a try-catch for it, just in case the hardware support isn't there, or there's an action that you're trying to use which just doesn't work in whatever setup each individual has. This is my Mac. So in the top right corner where I've got the battery and the date, it will come up with, when I'm playing this track, it will come up with this little play icon in the top. This is the screenshot before I've added that metadata via this API. And you'll see the difference. This is after. So it's got like a nice little thumbnail. It's got like the title. It just looks a little bit nicer. Chrome also does this. This is before. So right in the top right-hand corner of Chrome, you get this like little music note, and you can click on that. This is before. I like this. That's after. That looks good, doesn't it? The other thing that Chrome does, which is super interesting, is if you do have different sessions in different tabs, it will actually list them all. So one of the good things about this is you forgot that you had that podcast tab open, or YouTube, or whatever it may be, and it starts to play, and you're like, oh, crap. Instead of trying to search around for the tab or the window, you can just go up here and be able to play and pause and stop and do all of those sorts of things. Yes, we got our audio. We made some drums. We've made sure the browser knows the media, the metadata about it, all that kind of stuff. But we do need lights, obviously. It's a disco, right? I know. So much skill in this. I love that. This is a Canvas 2D element, and I'm just drawing a row of circles on it. One of the things I really like about Canvas these days is off-screen Canvas. Now, there's a couple of ways that you can use this. You can use the Canvas element, you can create the Canvas element, and transfer control to off-screen, and then post that canvas to a worker. And we have request animation frame in workers now. So that's super powerful. You can basically just offload all of your Canvas code to a worker. But one thing I actually really like is the other method where you just create a new off-screen canvas. So the circles that you saw is basically my on-screen canvas. I have a canvas element in the HTML, and I'm actually selecting that and drawing to it. This isn't shown. It just creates one that's there, and nobody needs to see it. And I can still use the same drawing methods on it. One way I really like to use this is for things like patterns and gradients. So what you're doing on a canvas most of the time is you're setting up your path, you're drawing your squares or your circles or your paths, and you're filling them or you're stroking them. And you can do that with color, or we can do it with patterns, and we can do it with gradients. So my pattern here, you can use an image, you can use a canvas element. I'm basically just creating a new off-screen, tiny little off-screen canvas. And then I'm going to draw on that the pattern that I want to fill, and then use it to create a pattern. There we go. That's better, isn't it? A bit more light-like. We might want some more. There we go. We're getting there. One other thing, this isn't new, but I'm not sure if people really know about it, and it's one of my favorite things about using Canvas, actually, is you can create a path 2D object. So normally when you're drawing on Canvas, you see canvas, arc, draw my circle, canvas, fill rectangle, fill my rectangles. This just holds the actual path for the object. It doesn't, it sort of separates it from the canvas itself. So over there, I can draw all my shapes and have all my symbols, and only when I actually want to do my drawing and have my loop can I sort of pull them in and use them. So I find this really, really useful. This is the one for the circle. So the circle for the lights and the pattern circles are all using the same thing, right? And that means I can just have a library of shapes and just pull them out and fill them whenever I want. Another feature about this, which is less known but also amazing, is you can insert the D attribute from SVG. So if you've got like something kind of weird shape, or you want to draw a shape, or you can't quite get what you want from circles and squares, you can just put an SVG in. Cool. We all know what's going to happen now, don't we? Yeah. Let's stick an analyzer node in. I've already got my audio context. This is a feature from the Web Audio API, and what it's going to do is it's actually going to analyze the audio that I'm playing and give me back a gain or a volume value for all the frequencies that it can find in that audio. I had to put this in because I forget. There is flashing lights just about to happen, and I should have said that at the front, shouldn't I? Should we ramp it up a bit? I feel like day disco isn't quite going to make it up to the evening, is it? Wait to time, right? There is one other thing, of course. I have buttons, and those buttons don't need to play sounds. I can make them do things on that too. Right, they are just buttons. I'm just listening for the buttons. Just before the vocals come in. I knew I was going to go under. I don't know, 25 minutes. It was all right. There is one API I haven't worked into this talk, but it is worth a mention because it's coming. It's sort of here. It's sort of coming here. Web Codecs API, which is really super interesting. When I was doing the encoding into the audio API with the data earlier, this is kind of thinking about that a little bit more and being able to encode and decode data and streams, audio, video, that kind of stuff. So there's not really a lot of it in the talk, but that is your homework. Go and have a little read about it. It is interesting. It's getting implemented sort of at the moment. And that's really it. Thank you very much.